Okay, welcome everyone to this week's compiler architecture meeting. So on today's topic is going to be Nazim talking about a plan to re-architect the options processing that occurs in the compiler component. This is something that's been long overdue, and I think that we're hoping to make some good progress on this over the next little while with everyone's input. So I'll turn things over to Nazim, and he can talk us through.
Okay. Thank you, Daryl. So thank you all for coming to this meeting. So today I am going to be talking about the plan to rework the options processing framework. And this has been a topic that I hear has been brought to the discussion table a number of times in the past. But now that OMR is an open source project, it's very important now that we make things easier to deal with when it comes to options processing, so that new developers coming into working with the project has a much easier time dealing with it. So what are the motivations behind pushing for this kind of rework? And I have mentioned that in an issue that I opened recently, and I will just go over them again in case I did not have a chance to see that. So there are a number of limitations that exist within the current options processing framework, such as, currently, like, the options class seems to do a lot of things that do not have anything to do with options themselves, and it seems like it's handling limit files and parsing of command line options and so on, and it really should be split into other more specialized classes so that it doesn't seem like a giant blob of a class, and it's much easier for someone looking at that class to understand what it is trying to do and what the functions are. Going on to the next limitation we have is that there isn't a standard way to look up information regarding options. There is no consistent way of looking things up within, like, per compilation context. Often the decision gets passed on to like the code generator or the global options object and so on. But it should really be something simpler, where there is a central querying mechanism, and and whatever needs to be delegated to other places can be delegated accordingly. So that's one limitation that needs to be addressed as well. Another issue is the option names. So they don't really follow any kind of consistent pattern. So some options that are Boolean, that contain Boolean values. So they have, for example, the name of a feature, and then it's assigned true or false. And some of them have Boolean values, but have, like, enabled that certain feature is enabled, and then it has true or false to that. But like, having a consistent way to have, like, a feature X enabled or disabled. Like, we could just have feature X and look up the value, whether it's true or false, instead of saying, like, enabled feature X true. That's going to shorten some of the option names and also bring some consistency to the options we have. Also, another issue with the options are that they're not available very early on in the JIT startup, so we don't really have full control over some of the operations that happen before CR options are available. And we need to be able to access it very early on, so that we reduce having to make use of fe getends and so on. And another limitation is that in the options table items structure, we actually have to order everything in an alphabetical order, which is one of the kind of barriers that many developers wouldn't choose to add their options there. It can, it's just another barrier, and if we can get rid of that, it would be nice. It's probably not a very major problem, but it is still something that may be worth solving. And another limitation we have is that the user cannot output the list of options that are in effect easily. So can't really know what exactly is going on and what kind of options can I try toggling right now to see the outcome. So having such a mechanism would be nice. And also another limitation is we don't have any options compatibly checking mechanisms. So some of the options, they conflict with one another. And sometimes the only way to know that you can't really apply two different options at the same time is just watching the JIT crash, basically. So if we are to solve that, it means that we have to maintain a list of compatible options when there are potential conflicts, and I don't know how how much usefulness we'll get out of maintaining such a thing, because it can be quite tedious doing that. So another problem is that we don't really have too much documentation on how to add options on that. The existing documentation is more about how to use them and where to look up the different options. But when it comes to adding, there isn't really much documentation on that, and I think having that would help new developers make use of it. So these are the limitations that are primarily driving the plan to rework the framework. And in order to do that, there are certain things that we are going to do. Okay, so the first few things that we plan to do is specializing the TR options into more specialized classes, and creating a central feature querying mechanism that is more compilation thread specific, and checking to see whether it causes any significant performance regression when we do implement it. Because one huge advantage of the current options processing framework is that it is very efficient, and it is going to be very hard to beat when it comes to the runtime performance, given the number of querying that happens within the compiler. Okay, so far, does anyone have any thoughts?
I'm not really sure what more specialized classes means. I don't know what the delineations are that make any sense in that big blob of joy that we all work on. So I'm not clear on that. I would also say that degradation in performance when it starts impacting compile time will not encounter huge tolerance in the Java world, right? If the options querying gets significantly slower, there will be a lot of resistance from the OpenJ9 project to adopt any kind of framework that does that, because compile time is time taken away from user programs, and users tend to be pretty good.
I think that's I haven't got to that yet, but I think that is definitely one of the primary features, design goals, is to actually make sure the performance is at least the same and hopefully better than what's currently there.
Yeah, hopefully there's so much code that runs.
But I mean, I think the problem that one of the problems that exists with the options class at the moment is that it does suffer, like other parts of the compiler, it does suffer with a bit of a conceptual integrity thing where it tends to do a lot of different things. I think the separation that Nazim was talking about is really to identify what those sort of independent pieces are, the processing of the actual processing of the command line, the actual, like the regex processor, determining whether or not an option is on or off, that kind of stuff. All those sorts of things kind of being separated out into the different components. I'll let you answer the question.
Yeah. So the answer to the first question you had about what the different components are. So limit files, for example, are basically totally handled by the options class, and so is processing of each of the different options. And I think they should be in a different place instead of a place that contains the information that is needed by the rest of the code to query from. So when I was talking about splitting options into those different components, that's what I meant. And it is also the first step towards reworking the framework because it kind of lays the foundation for any different implementations to come into place. And your second question was about performance, and and of course, and this is one thing that we're going to really work on to ensure that we don't really sacrifice performance in the name of more convenience. And we're going to verify that along the road. And okay, so let's see. Okay, so now I want to ask you all about what kind of ideas that you wanted to share about how a new options processing framework would look like. What is one limitation that you think that needs to be addressed?
So that we can have options that apply to subsets, that it can be put into sub-project, like projects that derive from OMR. So one of the major pain points for the OpenJ9 project at the moment is that there are options that exist in the current OMR options.cpp that are very clearly OpenJ9 options. They are there to control OpenJ9 behavior, but they need to apply or be used in a subset context where you're going to match a method or an optimization level.
Yes.
And at the moment, to have that work, the option has to be in OMR. So there's a significant number of pull requests where basically it's the addition of an option, which is not used by OMR in any way, shape, or form, to then be consumed in OpenJ9 because the OpenJ9 options processing logic cannot deal with the subset. So even if all we got working was that, you would cut a fair amount of churn out of the OMR code base from OpenJ9 people just sort of blundering through, dropping their options in left, right, and center.
Yes, and this is one of the biggest limitations of options processing. And if we allow this practice to continue, and in the future, if more projects make use of OMR compiler technology, we're going to see a lot more project-specific options in there. So, and we can't allow that. It's already a kitchen sink, and can't let that get worse. So, getting to that is something that we really want to see. But at this time, like how that's going to turn out, I don't really have a clear answer on that. Because first I need to go forward with some of the refactoring work that needs to be done, and then see what can be done about separating the OpenJ9 specific options from OMR options.
I think there's also some insidious dependencies that are going to have to be looked at, because it's possible to change options during compilation, and there are parts of the optimizer that rely on that behavior. certain optimization does or does not do something, it enables or disables something. That behavior can be very subtle, and if you change how all of that works, you may introduce some very subtle bugs, not functional, but possibly even performance bugs, where you can get very strange behaviors from the system.
Using options to do that.
There are parts of the code that do use options.
So one of the problems, I think that you didn't get into too much detail, but if you actually look at what's in the options, it actually has a lot more responsibility for making decisions about even like which method gets compiled and how it gets compiled and stuff like that than it probably should. It's not just an options process where it actually
Which of the OpenJ9 heuristics are embedded.
Yeah. So we have to, or we should, separate that surgically from this class in a very careful way, of course.
Mm-hmm.
But like it really needs to get a jolt of common sense in that code just to make it. So
well, I'm not saying that there shouldn't be common sense in there. I'm warning you that there's some areas of extreme nonsense that everything will look like it works, and some of the benchmarks will run just fine.
Yeah.
But there will be some cases where everything goes horribly sideways in ways that are not at all.
There was a recent example. I think there was a performance regression on in OpenJ9 that was related to some changes in the options. So certainly aware of that. And
did we get to the bottom of that one yet? Actually,
nope. Too many other things to look at.
Nonsense.
Yeah, my God.
It's a bug in that code.
Yeah. For item number 3, be very careful with TR enable OSR and TR disable OSR. They are not inverses of one another.
Okay.
Sounds
confusing.
Oh, it's the most awful options processing logic, I think, in probably the whole thing. TR enable OSR and TR disable OSR are not inverses of each other, and they are set differently in different places of the code.
Are there other examples of that? I've seen those in the past, actually. So I know they have exist. They do exist. But, I mean, ideally, we should get to a state where that's not the case, right?
I don't think it's particularly common to have, first of all, have two options simultaneously, one for enabling and disabling.
Usually gets renamed.
It usually gets renamed. Yeah, it's enable something until it becomes
disable something
real, and then gets changed.
Like the turn on renames the option as well as flipping the bit.
Okay.
But the enable OSR, disable OSR is one that I know didn't go through that process, and actually different tentacles have grown out of both parts of it. There have been at least 2 attempts to fix that, and we all just got befuddled by exactly what it was doing.
Okay. I think perhaps merging the JIT and the AOT options story might be
please.
A worthwhile goal from this.
Knowing which one applies in which order would be.
But what is the baseline, so to say, for an option? If I have PR underscore feature X, is it enabled by default or disabled by default?
Oh, no. So about that, so what we want to see is like some kind of a default setting that gets overridden only when there is when it's like specified in the command line. So that's how it.
So are you envisaging then, like, we currently have like xjit, disable loop strider. So are you saying that we have xjit loop strider and that flips the sense or something? Like what? I'm not quite clear on what the proposal is there.
So
I thought there was a character in the option descriptor that said whether it was on by default or off by default.
You mean that double quote F, double quote
Yeah,
T?
that one.
Which is not used anywhere?
Well, normally you just get you find an option that looks like the one you want. Obviously.
Yeah.
So nobody actually knows what it is anymore.
No, they're not set in any sensible way.
But I think that maybe the point is that we have to have some kind of a mechanism for sensibly describing the default behavior through a feature on or off. You're talking more about the command line, the syntax of the command line. how to enable it or disable it. So,
Well, I think there's the command line and there's the defaultness, right? One of the downsides of having the default specified where the actual option is declared is that in places where people are querying the option, you have to then go back and find that to know what the default was, right? Like in the scheme where you have tr disable whatever, implicit in that is, and all recent options adhere to this pretty religiously, that disable is like going to be like the state is like the default state is encoded in the name, so that when you're reading if option blah blah, you know what sense the test needs to have for it to work by default. And if you remove the enable or disable, then the piece of logic that you need to test whether the condition has the correct sense, whether it should be a positive test or a negative test, then has to be done by referencing whatever the default was.
You just pull that into the name. So is enabled, is disabled, and the option, I think.
But instead of get option, you get enabled, get disabled.
Right. That's just that.
In any case, it has to be preserved, I guess.
Right.
Your main.
Yeah, well, I guess what I'm saying is I don't want to have to go to some remote place to find out what the default is.
Yeah.
I don't think anybody wants that.
No. I think more of our concern is having the ability to specify when creating whatever set of options, being able to clearly specify what the default value is when you're creating the option, something that is more meaningful than double quote for whatever the magical characters are.
You should be able to enable and disable every single option, hence the option. Which I don't think is the case today.
So another feature discussed was having some sort of like a configuration file. So just like we can specify a verbose log now, like maybe in the command line we can specify a configuration file from which options can be read. In that way, it prevents us having to re-enter options again and again, especially when it's like a long set of options. So what are your opinions on that, and how do you think would be the best way to implement such a thing?
Those are two very broad questions.
This is to replace tier options?
Oh no, this is just being able to set options using a config file.
Is that not the same as processing command line? Command line is just a string.
Yeah.
File is just a string. Same thing, right?
So like
file would just be everything after the xtick call.
The format of it is like it should have like all the options that are like one thing we can do about it is like the default values probably could be part of that config file, and in that way like the user can easily know that okay, these are the config files and I can just toggle them. And another option is just being able to have like the config files just blank, and if you want to add any specific options through the config files, you can just add them there.
It would be useful if, let's say, in the verbose output or something, you could swipe the command line options that were used to run the JIT at that point, and then re-input those. Like I think we dumped them right now, but it's not really in a consumable format. And I don't even know if we dump all of them at the moment. I've seen that, but if we could kind of cut, paste, and then you've got the same kind of environment in theory again.
Sorry, I'm not sure I understood what you were suggesting.
Me?
Yeah.
So in the verbose log right now, we get listed all the options that we know about that are currently set.
Yes.
So if I...
But that's a subset because some of the options say don't print me.
Okay, so let's say we allow all the options to be printed. Why would you say? Okay.
Because you get 4,000 things.
Right. So, right, so if you had that in a file, and you could re-input into your, if you.
I mean, consume options from the verbose log, basically, to try
Yeah.
to reproduce the environment. Yeah. All right, so it's a playback kind of facility for verbose logs. Okay.
So there was a mention of FE get ends at one point. So what's the like somebody said something about FE get ends, and I'm not sure that I followed what came after it. So is that in or out of the scope of what we talked about?
I think there's still going to be, and you can correct me if your thinking is wrong, but I think there's still going to be a number of ways that you could potentially input option settings. I think we want to restrict it a bit as well. Like we have an environment variable approach right now with FE-getIn. There's command line stuff, but then there's other environment variables as well that are also being consumed. We probably want to maybe as much as possible reduce that to one. Nazim was talking about FE-getIn. He was like early on in the JIT life cycle at the moment, the only way that we can actually consume any kind of or affect any behavior externally is with FE-getIn, because options aren't available at that point. So talking about getting rid of that dependency early on. I think that there are some scenarios where it's difficult to get access to the command line. It's probably more easier to actually inject an environment variable. So if we needed to influence behavior, so.
I guess one of the fundamental questions here is whether OMR is opinionated about how you specify options or not, right? Is it up to the runtime to decide what its options look like? Like, should enabling the JIT be -xJIT? Should it be -J? Should it be -JIT? Should it be whatever like the runtime wants it to be? And then somehow that should, enabling the JIT's a bad example, but it may not be, not every runtime is necessarily going to want to add a command line option that looks reasonable.
I think the compiler can standardize everything after the current -xJIT : we can probably standardize that. And how you get us that string is up to the runtime.
Right, okay, so that's the same assumption that JIT builder made. Might be reasonable. I guess it comes down to, so then the second question, I guess, is related, so this was identified, well, because it's at this meeting and it was specifically identified as affecting how compiler options work, and we've been talking primarily about how to re-architect the compiler options stuff. I guess the question becomes why does this have to be just a compiler options question? And if you broaden it to more than just a compiler options question, then you lose what you just said, because now you've got, or I guess you end up asking runtimes to provide a -OMR option, which gives you all the options for all of OMR, not just for the JIT at that point, I guess. Anyway. I mean, I think there's some larger questions here around what does it mean to be consumable for language runtimes and specifying options and being able to configure things. So, is it strings? Is strings the currency of indicating options between OMR and a runtime? Is it some type of configuration structure? Is it another valid way of doing it? That define a struct, got a whole bunch of stuff in it, as well as some functionality for changing it, and then you pass in the struct as part of your initialization for OMR. I don't know. I mean, I'm not saying that's a good way to do it. I'm just saying that's another way you could do it. Doesn't handle option sets very well, but modulo that. So I guess thinking about how it is that another language runtime would want to communicate its values, maybe not just one, certainly not just OpenJ9 anyway, because we have heritage there and already works that way, so it's necessarily pushing us towards that direction, but other runtimes might not. I mean, I know when we've done most of the porting projects that we've got right now, we've been relying on, well, the ones that use JIT Builder have a way to specify options using the initialize with JIT options initializer, which takes a string. Although it's not super easy to use because you have to replicate the ones that JIT Builder knows about and he doesn't tell you what those are. And if you're not based on JIT Builder, then you're kind of in the world of setting TR options, which kind of sucks as a mechanism for setting options in a generic kind of way. Like, you don't want to ask a Ruby or a Python or a whoever to be putting things into their environment so that they can configure a component that they build with. That's just I think that's a non-starter approach. It's just kind of the way where we're at. But what is the preferred mechanism for that, I guess? Right? Is it still strings? Is it something else? I guess those are some of the larger questions I've got around this. I don't really have a feeling for, I guess I'm curious what other people think that way.
I guess if it wasn't strings, then that could allow a consuming runtime to define completely their own syntax for options. Like it doesn't even have to be.
Yes, right. So there's some attraction to that, I think, because it would allow us to, forgive the word, divorce OpenJ9's option processing, which is obviously set up a particular way around strings that they've grown to know and love and rely upon, and it would allow OMR to, possibly adapt that syntax underneath the covers if a better syntax would be more appropriate. I'm not saying we should do that, but it would open the doors to being able to adjust our syntax without necessarily impacting what an existing runtime would need to do.
Yeah.
Maybe.
Yeah. And in the case of OpenJ9, they actually have command line options that are consumed by the JIT that aren't even part of -X JIT, right? Like the X block reservations and stuff like that. So if all those were potentially folded into a single structure of some sort that just gets consumed, regardless of how that gets produced.
Right. So if we're going to re-architect options processing at the OMR layer, and we have this big heavyweight consumer called OpenJ9, which has built a bunch of its operating options processing on top of the OMR facilities in the compiler and outside the compiler. So we kind of have this like multiplicity of options implementations. It's going to be really hard to re-architect, I think, at the OMR layer without being forced to do it also at the OpenJ9 layer, if you know what I mean. Like we'll have to do a crap load of work in OMR already, because this is what we're changing a fairly fundamental infrastructure piece of the compiler and hopefully OMR eventually, like the rest of OMR as well. But I don't think we can get away with doing that without also doing exactly the same things in OpenJ9, which is another whack load of code that, yes, we know the developers who are able to make such changes, but it just makes the job that much harder.
Well, I think a refactoring of this magnitude, you're going to have to end up with some block step changes between the two projects to not have.
Yeah, I don't think you can avoid that. I agree. I guess I'm wondering if it has to be like OpenJ9. This only works if OpenJ9 and OMR move completely to a new options implementation, or is there some intermediate ground where we can test the waters in OMR and see if OpenJ9 wants to adopt at a later date or something?
So there's a lot of work that can happen without even touching that boundary, right? Because, what you're, I think, touching on is how do you input the options into the compiler technology or whatever in OMR. And a lot of what Nazim was already talking about is how it gets consumed internally. How do you check to see whether or not this feature is enabled or not? Where is the one place that I go to ask if this is on or off? So a lot of those concerns can happen independent of how the options get inputted. So we can stage things in some ways, if that's the way
we're going to go. One additional thought that I'd had a while ago, and I don't know if it makes sense in the OMR context or not, but if you look at LLVM and the way that optimizations there add themselves to the pass manager, right? So there's a pass manager, and there isn't a pass manager file where you go and list all of the passes. The pass has, in OMR's case, it's a template like that, but whatever. There's a template that gets instantiated, which basically adds the pass to the pass manager, right? So the act of building and linking in the pass takes care of bolting it into the infrastructure, and that also includes some options, processing, and various other things. So one of the things that I don't like at the moment about the options processing is that the options are removed from the place where they're actually defined to be used, right? Like, so you have options that control loop versioner, you have options that control loop strider, you have options that control idiom recognition or whatever. All of those options are over in the options.cpp in the global list. To know what the options are when you're looking at the optimization requires you to go and look at that table.
And know what to search for.
And what to search for, which is not always obvious, right? Because sometimes there are internal options that don't even include the name of the actual optimization, right? And you have to find them, and then you have to find out which of them are in there and figure out what their state is, and does anybody toggle the state in any of the pre-processing logic, and blah, 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 blah. So to me, it would seem nice to have the option of being able to have a way of going, here's the optimization, and at the top, or whatever the coding convention is, here's the list of options that can, these are the command line options that we want to expose that control this optimization. And if my project chooses to link in or build and link in this particular optimization because we're going to use it, then that gets put into my option structure kind of just by the act of having done that, rather than having to go and say, well, where's the OMR options list? Okay, now I need to go and put whatever I need from that into my default config, and somebody changes the default in OMR, I've got to change mine, making it more declarative and local to the place where it's being used.
So it helps with the documentation effort, right? Like it's
right.
Much easier to document options in the context where they're going to be used.
Right, and also they make more sense because they're in the context where they're being utilized. Now, it's not true for all options. Some options are global and kind of we do need a global place to put them, but for some of them, having a local place to put them.
Big subset of those, a lot of the Cogent ones where enable x87, like none of the other Cogents other than x86 cares about that option.
Right, but in the floating point that you could put the options to control the floating point evaluation in the top of the floating point evaluation evaluators, like file. There you go. That's where you can put the x87. And when you build on Z, there isn't an enable x87 floating point or whatever because that file wasn't linked in. Right. So it's a bit different than what we do at the moment, but I just thought I'd throw it out there because maybe having the big global list of everything, especially through composed enums and whatever else we end up doing, maybe that isn't the best way to build this so that we don't all keep trying to check into the same file at the same time.
I'm trying to put this together with your statement about not making options processing any store, but that's okay.
Well, I don't know. It depends how you, it depends how you do it because like with the LLVM one, it's part of the static initialization. Yeah. So the very act of loading the library does it and you only pay that once.
Yeah, no, I understand that. I guess it's getting to the point where
that is
checking an option is pull a word out of the, like pull an options word out and mask a bit, right? Mm-hmm. That's what it costs to check an option right now. Mm-hmm. So, I mean, it's not that the enum couldn't be constructed dynamically from all the options that got created.
Yeah.
It wouldn't be a constant anymore here. So there would be some impact, I think, but probably not.
Yeah. Well, anyway, I'm not saying, I'm just putting out there as another design point, so like you were saying about the options processing, moving the options declaration to the place where it's being declared and used might make sense.
It would also So you were also mentioning about FE-get-N. I think one of the reasons people use those as well is because they don't want to add something to the options
100%.
table. So if it was more localized, this is just my code here, I can add my own option here. Maybe we would make less use of the environment variable approach.
Certainly possible. I think, though, that there needs to be a distinction between these are the options that I, as the developer, envisage as the ones to either enable or disable the feature or for general purpose debugging. Like, these are the ones that I want to tell the world about. There are another plethora of options which are very specific internal kind of debugging handles and tracing handles and things that if you're somebody who knows about that opt or whatever, you want to know about those, but they shouldn't come out on the command line as a list of things that you can use and things like that.
So one of the problems with using the FE-get-N, though, is that, and one of the huge advantages of what we currently have with all the warts this infrastructure has is the per method filtering of options, so the option subsets, right? Mm-hmm. So you can't get that with the FE-get-N. It's basically a global option that applies to all compiles. So if you did want to add some kind of finer grained control to whatever code you were working on, it would be better to have an option, like a command line option or something, rather than an environment variable.
I'm not saying that there's a problem with having it necessarily on the command line, though being able to set them with environment variables can sometimes be handy for other reasons. But having two classes, or at least two classes of options, those that I'm defining as my public options, which I will document nicely and I'll support and have various behaviors that I'm willing to describe. And then there's the internal handles, right? And that's the majority of what the FE-get-Env is today, right? You're deep in the middle of trying to debug VP, and there's a certain particular part of it that you're debugging, and helpfully the developer who was there before you left certain things that you can turn on to get more information about what's going on. Those things are in FE-get-Env because nobody ever wants to have to talk about them in the context of the command line options you can supply to the project, because outside of that very specific context, they have no meaning and don't deserve to be turned on. So there's almost sort of, the public and the internal almost. I hate using those words, but best set of words I can come up with. I'm sure it's the same for some parts of the code gen, like the register assigner, at least on x86, has a plethora of useful but not for general consumption environment variables of various kinds.
Okay, so I did think about localizing, setting up options, but in order to look at that, we need to actually see how much performance impact that might have, because so far, there are projects that did implement ways to localize options, and even tools that are available that will allow us to do that. So Boost library is one that allows you to...
Don't go anywhere near Boost.
No,
for the love of God.
So, we don't have to use Boost, but borrow some of their ideas. But then, thing is, right now I don't really have any answers to how much performance cost that will be, and if something like that is implemented, it might not sit well with others, especially talking about OpenGen 9. So,
well, compile time performance is definitely one of our the JITted compile time performance is one of the key metrics that we have to make sure that we maintain with this. So anything that we come up with has to be evaluated against that, for sure.
I think that with some creativity, you may be able to get some. You might not be able to get all of the benefits of those things, but it may be possible to do it without too much hassle. It may require a bit of creativity with how things are initialized. I wouldn't necessarily say that LLVM is exactly the model to go with, but it is a model that achieves something similar.
Can it handle conflicts among options? Like if I want to call my option enable foo and somebody else wants to
it's more structured than that because you're registering passes, so that the options are derived from the name of the pass and the sort of formulaic.
So it gets its own namespace, basically.
Yeah.
Yeah. Well, yeah, essentially.
Might make the option hard to specify. But...
Yeah, like if you detected a conflict, I mean, just naively, I'd say just make the whole thing fall over because it doesn't make any sense to try to resolve it.
Do we want to talk about the fact that we have, it kind of came up before, maybe I missed some of the discussion around this, but the fact that there are sort of areas of the code that need to ask different kinds of options, ask about different kinds of options. So for example, when you're inside a compilation, you should probably be asking questions about the current option set because that will take into account any option settings that are specific to the method that you're compiling.
Oh, yes.
Whereas if you're not in code that's running in a compilation, you need to ask a more globally command line options kind of question. And then Andrew is mentioning we have the JIT versus the OT bifurcation that I instigated on the world.
Thanks, Mark.
Which, yeah, you're welcome. There was a good reason for it at the time. It just went away after that. Although maybe JIT as a service brings it back. I don't know. Maybe not. And I guess well, if we unify the notion of the outer JIT runtime and the rest of the runtime options, I guess there's only those 2/4, 3, I guess.
So what you're basically saying is that we need to be able to have a mechanism for providing those different answers.
Well, and knowing which one you need to use, right? Because that's the state that we're in right now is that people use different things based on what code they're copying.
Right. So I think
it's not always the right thing.
It would be very helpful for developers if they, regardless of where they, and this is maybe aspirational as opposed to something you actually make, but regardless of where they are in the code, they can ask the question they need to ask.
Yeah.
And underneath, it figures out
which thing they should be asking.
Yeah, do I ask AOT? Do I ask the JIT? Do I ask the global options or whatever it happens to be?
That suggests that it should just be like you create an options object and you ask that thing, and we have a global options object that everywhere. I mean, actually, I'm wrong about that. Sorry, I'll take that back. Because part of the problem is the way we ask options inside an option set right now is by getting the comp object and asking about an option, right? So are you proposing a more static form of that, which goes and gets the comp object if you're in a compilation?
Or maybe if you are in the middle of a compilation and you have a compilation object, you have some kind of an options. I'm just making this up. You just have some kind of an option that's underneath the
make on.
An option that lives underneath the compilation, under compilation, and that's what's responsible for answering. If you don't have a compilation in your hand, then you ask the global.
Yeah, I guess I'm trying to figure out what code does someone write to query an option if they don't know if this code's going to be accessed in a compilation state versus in a runtime state. So, for example, code in CHTable, for example, might get queried while you're in a compiler because you're updating the CHTable based on something that's happening in that compilation. Or you might be being called as part of a class load or unload hook, and it wants to figure out how to tailor its operation for the table, even though it's not doing a compilation right now. So it would be nice if developers didn't have to think about that and just wrote, I want to know if this option's on or off. And under the covers, as you say, it goes and figures that out. The only way I can think of that is to see if there's a compilation object, like a TLS compilation object around, but that's going to kill performance if we do that. So, I don't actually have a point, I think, but
No.
I was just trying to explore the.
I think you're raising a requirement, right? And I think that is a requirement that, at least in some version of what I've seen, it's a goal for. I mean, we do always have. I think in any of those contexts, there is a thread that we happen to have our hands on. Now, whether or not that's a compilation thread or not is a different thing. So maybe there's some way of attaching this information to the thread.
Is end another place to?
So that's a whole other discussion.
Way to go, BJ.
That's going to be that's going to get
throw everything in the mix.
Yeah, that's going to get changed a lot too. Hopefully soon I'll come talk about some ideas for that as well. But that's actually the similar kind of concern in that the answer to some questions about the environment is different depending upon what you're doing. Like, am I compiling a shared classes thing? Am I compiling, or am I not? Am I outside of a compilation thread? That sort of thing. It's the same kind of difference that we have there. So there's potentially some similar solution that we'd have to come up with between options and the environment front end. So. But the one common thing in all those cases is that you do actually have a thread in your hand. Now, what you can do with that or what information we have available there remains to be seen. But so maybe the options, for example, has to live a little bit higher up it's not just in a JIT data structure. Maybe it has to live on the OMR thread or something. Maybe not that high, but
the OMR compiler necessarily have an OMR thread right now.
But anytime you ask a question of something, even at runtime, you'll have thread. Or if we're not asking
different question. I mean, you're answering a different question than I asked.
Okay. Did I get it right?
Yes.
Okay. Right.
Clearly, there's a thread. The question is there an OMR VM thread? So it gets created. Like in JIT Builder, for example, I don't initialize OMR at all as part of the initialized JIT Builder process, right? So I would be a little bit surprised, although maybe this came about through the port library stuff.
See how you initialize the JIT there. Do you actually create? We had this discussion on the initialization one. What do you pass in? Do you pass in null, or do you actually poof up a fake one? And I don't remember the answer.
Yeah, I can't remember anymore. So long ago I wrote this. But I don't believe there's an OMR VM thread around.
There's a fake one. There's a fake one, I think.
There's a fake one? Okay.
I think you put up a fake one in compile method builder or whatever. Is that what?
Because I think in the the port library initialization or something, there are things that start to indirect off of that thing, try to find out one thing or another. So
right. So that's what I was saying. This might have gotten incorporated as part of the port lib work that happened to make JIT Builder dependent.
But only to stop it from streaming. It may not actually be doing. Like sticking his tooth there in his mouth.
Put the duct tape down.
It stopped crying.
So when you're thinking of doing this at the VMs or at some sort of thread level, are you actually thinking of having copies of the options object per thread, or like I'd prefer having just one object that everybody eventually asks. And the main worry I have with thread is more than one thread,
But I guess I think it'll kind of come down to how
And we'll also
the questions that you were, I'm in a compilation context, I'm not in a compilation context, how much those are going to influence the answer. I don't know the design. Like I have to think about it, but
it also comes down to how early can you ask a question too, right?
Yeah.
If you rely on some other structure being around, you won't be able to ask that question until there is one of those structures around to ask. So, and in the primordial case, that might limit you if you have to wait for an OMR. I don't know, Robert can probably comment better than I can, but you may have to wait before there's the opportunity to create a whole OMR VM thread before you could. We've probably solved this problem already by not asking options questions earlier than that. But
does JIT-Builder create an OMR VM?
it didn't used to. I don't know. I have to go and dig deeper.
Because that's more of a static data structure.
So when I created it, all it created was a compiler. It did not need anything else. So, I need to go digging into the OMR compiler now to see if the the common JIT init does any of that stuff, or TR compiler initialize does any of that stuff. So I haven't looked at those in forever.
Okay, so I think that the to do here, I mean, that requirement is certainly heard, and we just need to figure out the most efficient way of actually making it happen. Right. And just out of, and I don't know if you'd be able to answer it now or not, is the feeling that you wouldn't want to actually create an OMR VM thread and an OMR VM, even for JIT Builder? Like if there's sort of a minimum set of...
So I think the question there will break down into how much of an imposition that will bring to people who don't want to create a full VM, right? So if you're using JIT Builder in a context where you're just trying to accelerate some computation and you're not trying to write a language runtime, I would prefer that not to carry along a bunch of baggage that won't be actually used for anything.
Well, I mean, if you didn't provide your own baggage, if you didn't provide, what I was going to say is if you don't provide your own VM thread or VM, it would go and create a default one for you that actually is, correct. It actually can answer questions properly. But then again, you're bringing in the VM thread baggage and the VM baggage as well.
Right. I guess so. I mean, it's a 4 megabyte library, and it probably doesn't take all that long to initialize an OMR VM and an OMR VM thread structure. And if it's not sort of exposed to JIT Builder consumers, if they don't want to know about it, then that's probably okay. But
right now, the compilation, TR compilation, that object has a pointer to the OMR VM thread. So there is a dependency there.
Which means it must be null if we're not compiling that.
Or fake.
Yeah.
Sorry, could you read that, Robert?
We can't hear you very well. I think it might be fake. Like, I think that you pass in a pointer to some stack constructed bogus thing.
Oh, charming.
Even worse than null. You answered the wrong answer.
Right.
Here's some random answers.
I don't know. I tend to think that it's almost outside of the scope of JIT Builder to try to do any kind of VM-wide smartness.
VM-wide what? Smart?
Like smarts. Yeah, to have any kind of knowledge of like VM access or heap access or anything like that. It almost seems like it's outside of the scope of JIT Builder. I'd like to be able to construct my own VM thread and then attach like a JIT Builder context to that somehow, like sort of stuff a pointer to a JIT Builder context. If I need it. And if I don't need it, then I don't bother.
Okay, so where this becomes important, though, is that, I mean, it may ultimately influence the design of this, because obviously this is going to be used in a JIT Builder world.
Yeah.
Oh.
So the options, aren't they attached to like some sort of thing that you're compiling, not really attached to the thread? Or at least the physical thread, like not attached to a physical thread, it's some sort of compilation object that has the options on it?
I mean, currently?
Yeah. Well, or conceptually, like, isn't this something that we would want? Like, this is how it should work.
No, currently, there's a compilation object that's allocated per thread that's stored in TLS that has an options set hanging off it, and that's where primarily compiler code should be asking questions of that option set.
But that has been
not that
already
that's universally true.
That has been filtered already based on the method that you're compiling.
Yes. Yeah.
And then the global one, I think, lives in either persistent memory or JIT config somewhere.
Okay.
On the OpenG9 side, at least.
Yeah.
Yeah, static access or get JIT command line options and get AOT command line options.
Yeah. So for the duration that a thread is compiled, so there's only ever one thread compiling like a method at one time, and for the duration of that compilation, that one thread, it isn't doing anything else. It's just compiling that one thing. So there's like a one-to-one relationship between a compilation object and a thread.
Yeah.
Yes, the compiler thread's doing one thing. It's not collaborating with other compiler threads on that compilation.
Yeah.
Okay. Yeah, okay, that makes sense to me. It's yeah, and so you guys were talking a little bit about maybe hanging the compilation objects off of the environment, like off of the not the JIT environment, the VM thread.
That is, well, if there's one thing that like when you're asking a question outside of a compilation context and within a compilation context, the one thing that both of them, JIT Builder notwithstanding, has in common is the fact that you actually have an OMR VM thread, at least somewhere. And if we had to hang something somewhere, it could be there. But if JIT Builder just has a fake one, then that's something we need to look into and understand if there's an alternate way we can do this or require JIT Builder to have a VM. I don't know.
Okay, yeah, I'm not jumping up and down screaming. Yeah. So that probably, if it's whatever thing is hanging off of the current OMR VM thread, then that probably pushes you closer to a world where you are going to combine the JIT and AOT command line options into a single command line option object, which I know Andrew's happy about, although it comes with complexities.
Oh, of course it does. Everything does.
Just one reason why I did it that way in the first place. But in retrospect, it probably wasn't. It was going to be half a dozen of one versus 6 of the other. Like what I did was complicated and nasty, and doing it the other way would have been complicated and nasty too. So.
Okay, so if we do it the other way, we're going to get your other 6 nasty complications.
Yes. Well, so
do you remember what those nasty?
Yeah, well, I mean, so right now, optimization level doesn't take AOT into account, right? We have AOT cold, we can do AOT warm, hot, we can, like, you have that, there's 2 independent things, right? Optimization level and AOT. You need some way for the options processing to distinguish between the AOT cold and the cold compilation, right? Which right now, in the way we structure the option set descriptor, right? Right now it assumes that you can provide a hotness name, right, to distinguish it, which nobody almost ever uses, but I'm sure it's useful in some contexts.
It's used a lot by the op team.
Okay, sorry, fine. I take it back. I've never used it very much. It's been a long time since I've been on the op team. So if
you're welcome back.
Teach you how to use hotness.
Yeah, that's right. I'll remember reprogram myself for using options. But the way that load, which is another thing that doesn't exist yet at all as a hotness name. Load is kind of a different thing. And they're also in OpenJ9, an unfortunate part of the design of this code is that, so AOT loads used to be completely a runtime side thing. So all the code that did it existed in a place that used to not even know about compilation objects because there didn't used to be one. And then circa Java 7, we merged the heuristics for doing a load or a compile back into the compilation thread stuff. So at a very high level, there's this whack of code that figures out if it's doing an AOT load or some type of compile. And so there's two code paths there that I guess just kind of, all that stuff is kind of divorced and works slightly differently. And in complicated ways. Let's see, what else? One of the reasons why it was done originally this way for OpenJ9, or for J9, I guess, was that the original, it's kind of connected to what I was just talking about, you used to be able to run J9 without a JIT. So you'd only load the core runtime, and that had the ability to load AOT functions. And it seemed weird. The option that enabled the JIT was called -x JIT, and it was on by default. And if you didn't want a JIT and you only wanted interpreter, you could do -x no JIT. And it felt weird to have JIT options be listed as sub-options on -x no JIT. So -x no JIT, here are all the options you should use for AOT. Felt weird. So we ended up putting it on -x AOT because we needed a way to enable and disable AOT as well. And then once you've got an option to enable AOT, well, maybe the command line options for all of the AOT stuff should be there. So that's one of the reasons why we landed on the path that we did land on. However, I wish I had fully understood the full complexity of our command line processing stuff before I had embarked on that particular challenge, because it ended up duplicating quite a lot of code in the end.
Okay, we have to articulate every.
Yeah, I can't remember any other big ones off the top of my head.
Okay.
I'll think about it more. Move on.
Okay. Yeah, we have got about 18 minutes left. What do you move on to the next one? Or?
So, yeah, so like the other thing that I wanted to talk about was so this is something that Philip brought to the discussion. He was talking about outputting help text for each particular option, and like getting like the settings that can be applied on those instead of like kind of guessing what they are, because it's not possible to really document each and every obscure option, and it's probably easier to just have some sort of a help text that can be output right away. So one way to do that is perhaps
Sure, the help text describes how to use the option, or what the defaults of the option are, or what the current setting is, or what?
Well, it could be what the option does, and what are the values that can be applied. Like what whether it's true, false, or a particular name, of if it's like a file name, for example. So something like that. So
it's on an individual option basis as opposed to that
individual option basis.
large, not so useful table that comes out right now.
Yeah. Yeah. So some projects, for example, they take some set of options like -H and then the name of the option, and then it'll output the information related to that. So do you think that's something useful that can be implemented?
Yeah. Yes. Is it useful? Absolutely. Can it be implemented? Yes.
Yeah, it's
Can it implement it efficiently?
Okay. So, and another thing is that as we go forward with this rework, I don't really want to have people learn new ways to, like, new option names to enter in the command line. Like, supporting the existing options are very important, and just wanted to mention that so that you're not really worried too much about like losing your way when trying to work with options from now on. So initially the main effects that you're going to feel are how the options are queried. It's going to be a different kind of mechanism, and also how they are named internally. So they would be, there will be a more consistent naming scheme that I spoke about before, and also there has been, so Philip also mentioned to remove the TR prefix, which I don't think is needed anymore, and Luke helped pointed out that it was just historical reasons why we have it, and I think removing that is probably going to be not a problem.
You may end up with a number of name clashes.
Yeah, that's what I was wondering about.
Name clashes in what?
Well, like somebody has a bool that is the version of the option without the TR underscore is certainly one common pattern. Right? You query because you don't want to keep querying the option in certain circumstances, so you create a local bool that holds it, or
You might get lucky. It might not be capitalized in the first letter.
it might not be.
That wouldn't be confusing at all.
No. Or there might be, FE get env stuff that's being combined with options processing stuff where names are being repeated. I just warn there be dragons.
It's an aspirational goal, but I think it's going to be potentially a lot of tedious work. That doesn't mean we should do it.
We can remove from the repo.
Pardon?
Think of all the characters we can remove from the repo. No longer have to type.
Is this how we're going green? Like we're reducing the number of characters in our compiler?
Team will collectively grow 2 pounds because of all the typing.
Anything else?
Well, that was it for me. I just
I have a nasty question. I'll try not to ask nastily. Do we have a strategy for trying to avoid problems like the one that did us when options got changed before in seemingly intelligent ways, but then caused performance regressions? How are we going to not fall into that trap?
So I looked into that problem we had, that was faced a little bit, and I don't really have an answer yet what the actual cause was, and apparently it was because of getting the incorrect value when the compilation specific option is being queried as opposed to the global options. So the thing is that what we are envisioning is something like a central option querying place that will take care of asking the global if needed.
Mm-hmm.
And right now, I think I don't have a clear answer about how we are going to detect what kind of problems are happening, except actually running the benchmarks and the different tests that are currently being used.
I think for some...
I have a suggestion.
Yeah, go ahead.
So if we're going to move towards a model where you ask one question and it gets decided which one it's going to ask, as an intermediate step, before we commit completely to that single thing, you change, instead of just changing it to whatever, ask that thing about this option, you pass an additional option which says, what was the original query that got asked here? And then you can easily find cases where you are choosing the wrong, right? You can verify in the service that you chose the right answer. And then if something goes wrong, you have a set of candidate places to look for what went wrong, at least.
Would almost be useful even.
And then once we assure ourselves that everything's good, then you can do a simple set replace to get rid of the option that gets passed in.
Okay.
And then we're in a happy place, maybe.
I wonder if there's an easy way of
Code might
actually
not look
building
later.
something in parallel with what's currently there without incurring a huge amount of overhead. Like that would be the problem. And then you can do those kinds of comparisons. Because otherwise, in order to get that
I guess you
answer
could
back,
start-
you're going to need to have the existing infrastructure there.
Well, you could start by overriding comp get options and get command line options, get AOT command line options, because that's what the code base is using. Implement your service there, right? Underneath those queries, so you already know which one's being called, and then see if your service predicts the right one. Right? You can have that change. So nothing changes in the code base yet. You can implement your service, and then once it's good enough, now you can push out to replace all the calls to comp get options, the calls to get to command line options, and calls to get AOT command line options.
Okay.
Maybe. I don't know. I'm sure that's going to be harder than I'm thinking it will be, but seems like a starting point. Because that way, even people who are still working in the code base and copying things and creating new ones, they'll create whatever thing they think is the right thing to start with, right? Or whatever, whichever one they're copying, they'll get that one. And then you don't have to kind of worry about new people writing new code, needing to understand what it is that you're doing under the covers, really. People just keep doing it.
The frightening thing about that one particular performance regression was that the code looks correct. It doesn't look like it should be. And so it's...
There were a few places where it changed the where I wasn't convinced looking at it quickly that it was asking the right command, the right options object question that was being asked. And there were places where there was a set, which bothered me. But now Andrew says we do that in places I'm less surprised.
There's quite a bit, actually.
Yeah, I know. It just kind of bothers me that options is the way that we do that somehow. It's like there should be some other mechanism that controls. Like options should be what options were you given, not what options do I think are the right things.
That's the purpose of the feature,
Yeah.
the separate sort of feature class.
Yeah.
You ask that thing, is it on or off right now? All that'll answer.
Yeah, I'm more like one opt finding something or doing something and then setting an option to say something later should do something differently because, right? Like I understand the enable and optimization because I found an opportunity for this optimization that should get cleaned up later because I just created it. But the use of options to do that just feels squirrely to me. I don't know.
Where it's not contained to an opt in particular, you're trying to turn off part of an opt. Or
Yeah, no, I get it. I understand. It's just options doesn't feel like the right thing
Oh,
to
yes,
use.
so I'm not arguing for it being the right way.
I get it.
That can be the first task you give them on the opt team.
Okay.
All right. Well, you people know how quickly I deliver things, so you know what you're getting into.
So, what are your what's your current plan of attack here? What do you? How are we going to move forward with this?
So, so the first step that I'm working on right now is refactoring the entire code around options and like, and after that is done, like I'm gonna start working on like on the new feature querying mechanism so that, and like just seeing the impact of that on the performance or whether we're getting the wrong results or so on.
Okay.
And
I'm going to suggest that we, that we put our heads together. We should do this publicly as well as part of the community. But think about some of the requirements that were raised here and how, and the requirements that you have and how those are going to influence the design. Because I don't think that just sort of a straightforward, well, we need to make sure we have some kind of a solution in place that addresses as many of these as we can, as opposed to, let's say, just having a simple class or an object that we're just asking, are you on or off kind of thing. We need to have something that works in all aspects. So we should give that for sure, and then document what we're doing.
Yeah, for sure. And any kind of progress on this matter can be like followed in that epic issue. So
yeah, I think you should create subtasks under there.
Yeah,
and issues
yeah.
under
So they
there.
will all be connected to that.
We're going to summarize some of the requirements that we proposed.
Okay. So
yeah.
did you put them in the issue? The discussion that we had today, like in addition to what you already have and the topics that came up.
Sure. Oh.
Okay, any other discussion anybody wants to have on this? I mean, we're certainly going to keep that issue. There's going to be an epic issue there, so by all means, jump in with.
Feel free to add your thoughts there, and if you need more time to think about what kind of issues that might come up.
Okay. That's it. I guess we'll, thanks very much, Nazim. I guess we'll adjourn then.